Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space, 14.5 billion miles from Earth. But nearly 50 years later, Voyager is still alive, defying the odds. Recently, this legendary probe has encountered something in the void that has scientists both amazed and deeply concerned. What has there found Voyager? The data streaming back suggests phenomena that challenge everything we thought we knew about interstellar space. Today, we explore Voyager's impossible encounter and what it means for humanity's future among the stars. The birth of a star sailor. The story of Voyager 1 began in the era of Cold War ambition, when NASA sought to expand humanity's horizons beyond Earth orbit. Under the leadership of Dr. Edward Stone, Voyager 1 was designed as a robust spacecraft capable of a grand tour of the outer planets, the first of its kind. Launched on September 5, 1977, from Cape Canaveral, it journeyed towards Jupiter with an array of scientific instruments, including the cosmic ray detector and plasma wave instrument. The spacecraft was engineered to survive decades of space exposure, carrying the hopes of mankind as it ventured boldly where no one had gone before. Dr. Stone's decade-long stewardship ensured the mission's remarkable longevity, setting the stage for an unprecedented exploration of our solar system. Built with 1970s technology that would seem primitive by today's standards, Voyager 1 was nevertheless equipped with instruments sensitive enough to detect the faintest signals from the cosmos. The spacecraft's nuclear power source, designed to last far beyond its primary mission, would prove crucial for its extended journey into the unknown. This remarkable engineering feat would soon carry humanity's message to the stars and beyond. The Grand Tour. Voyager 1's Grand Tour of the solar system became legendary, lasting over 12 years and bringing humanity close to the gas giants Jupiter, Saturn, Uranus, and Neptune. During flybys, it sent back unparalleled images and life-changing data that redefined our understanding of these colossal planets. Notably, the encounter with Jupiter revealed the planet's turbulent atmosphere and intense magnetic field, reshaping planetary science forever. The spacecraft discovered active volcanoes on Jupiter's moon Io and revealed the complex structure of Saturn's rings in unprecedented detail. Subsequent visits to the outer planets expanded our knowledge of ice giants and their mysterious moon systems. Each planetary encounter used gravitational assist to propel Voyager faster toward the edge of the solar system, a trajectory carefully calculated to maximize scientific return. The spacecraft's cameras captured images that became iconic symbols of human exploration, including the famous pale blue dot photograph of Earth taken from 4 billion miles away. Voyager's trajectory, programmed for a final sprint beyond the solar system, demonstrated NASA's engineering brilliance in interplanetary travel. Today, its legacy continues as it ventures into interstellar space, humanity's first emissary beyond the protective bubble of our sun's influence. The Golden Record. The Golden Record aboard Voyager 1 is a time capsule destined to outlast humanity itself, containing sounds and images representing Earth's diversity. Curated by Dr. Carl Sagan and a committee of scientists and artists, the record includes greetings in 55 languages and music spanning cultures and epochs. Encased in an engraved gold-plated copper disc, it serves as a cosmic message in a bottle, intended for any intelligent life that may encounter it in the distant future. The record also contains scientific information about Earth's location, using pulsar maps devised by Dr. Frank Drake, providing a cosmic roadmap for potential discoverers. Despite its age, the Golden Record remains a testament to human curiosity and hope across the void of space, symbolizing peace and universality. The record includes sounds of Earth, from ocean waves to human heartbeats, from classical music to the laughter of children. It represents humanity at its best, showcasing our diversity while emphasizing our common bonds. Voyager's legacy is as much cultural as scientific, immortalizing humanity beyond our solar system boundaries. This golden message continues its journey through the cosmos, carrying our hopes and dreams to destinations unknown. Years in the void. Years of drifting through the cold void beyond our solar system, Voyager 1 has defied all expectations for spacecraft longevity. Since crossing the heliopause in 2012, it has continuously sent back data about interstellar space despite operating far beyond its design limits. Engineers at NASA Jet Propulsion Laboratory, led by Dr. Suzanne Dodd, have managed to keep the spacecraft operational despite dwindling power supplies and aging components. Voyager's instruments continue to measure the harsh radiation environment far beyond any planet's protective magnetosphere, revealing a cosmos more dangerous and dynamic than anyone imagined. The spacecraft's telemetry reveals vital signs including temperature readings and electrical system status, a testament to the incredible engineering resilience of 1970s technology still performing flawlessly in the most hostile environment known. Each year, Voyager's plutonium power source weakens, forcing mission controllers to make difficult decisions about which instruments to shut down to conserve energy. Yet the spacecraft persists, transmitting scientific data across billions of miles of empty space. Voyager 1's longevity contrasts sharply with initial mission expectations, with scientists noting it has become humanity's longest-lived emissary in the cosmos, far exceeding all predicted operational timelines. Crossing the boundary. Voyager 1's historic crossing of the heliopause marked humanity's first journey into true interstellar space, a milestone that redefined our understanding of the cosmic frontier. The spacecraft's instruments, including sophisticated sensors and detection equipment, began recording phenomena unlike anything seen within our solar system's protective bubble. Lead scientist Dr. George Glockler from the University of Minnesota explains the significance of these observations, revealing magnetic field turbulence and unexpected plasma oscillations that challenge existing models of the interstellar medium. The boundary between solar and galactic space proved far more complex and dynamic than theoretical predictions suggested, showing multiple layers and transitional zones rather than a clean separation. Voyager's data revealed that interstellar space is not the quiet, empty void scientists once imagined, but rather a region filled with electromagnetic activity and cosmic phenomena. The spacecraft detected charged particles moving at incredible velocities, evidence of ancient stellar explosions and cosmic events that occurred millions of years ago. These measurements provided the first direct sampling of materials from beyond our solar system, offering insights into the composition and behavior of the galaxy itself. Voyager's continuing transmission from this unexplored realm offers unprecedented insights into the boundary between solar influence and the vast galactic ocean beyond our protective heliosphere. Signals from nowhere. In late 2023, Voyager 1 went mysteriously silent, sparking fears among mission scientists who had dedicated decades to the project. Analysis revealed a corrupted memory chip, likely damaged by a high-energy cosmic ray that struck the spacecraft with devastating precision. Immediate action by the Jet Propulsion Laboratory team, including Flight Director Dr. Melissa Brown, involved rerouting computer operations to back up memory areas while working across an impossible distance. This delicate software workaround, performed from Earth with signals taking over 22 hours each way, required extraordinary precision and patience from the engineering team. The rescue operation demonstrated incredible human ingenuity, essentially performing remote brain surgery on a patient billions of miles away using technology older than most of the engineers working on it. When Voyager finally responded, it brought relief to scientists worldwide who had feared losing humanity's most distant explorer forever. The incident highlighted both the spacecraft's vulnerability and resilience, showing how a single cosmic particle could threaten decades of scientific discovery. The successful restoration of communication proved that even in the depths of interstellar space, human determination and technical expertise could overcome seemingly impossible odds and continue our journey of cosmic exploration. The temperature mystery. Voyager's instruments have detected bizarre temperature anomalies in the interstellar medium that defy current scientific understanding of cosmic thermodynamics. The spacecraft's sensors recorded unexpected heat signatures and thermal variations that suggest unknown energy sources operating in supposedly empty space. Dr. Reka Winslow from the University of Michigan analyzed data showing these temperature fluctuations correlate with mysterious electromagnetic activity that creates complex thermal gradients across vast distances. These findings indicate dynamic processes previously unknown to science, with energy transfers occurring through mechanisms that current physics cannot fully explain. The spacecraft's thermal sensors detected variations that challenge existing models of interstellar space, revealing an environment far more active and energetically complex than anticipated. These thermal anomalies persist across the spacecraft's trajectory, creating a puzzle that has scientists scrambling to develop new theories about energy distribution in interstellar space. The temperature readings suggest that the void between stars, may harbor energy sources or phenomena that could revolutionize our understanding of cosmic physics. Some researchers speculate these thermal signatures could indicate the presence of dark matter interactions or unknown electromagnetic processes that operate on galactic scales, opening entirely new avenues for astrophysical research and discovery. Changing course. Maintaining control over a spacecraft traveling through the depths of interstellar space requires unprecedented precision in navigation techniques and trajectory management. Dr. Carlos Hernandez from NASA Goddard Space Flight Center leads efforts to execute delicate course corrections on Voyager 1, despite the enormous challenges posed by distance and communication delays. These trajectory adjustments must account for the spacecraft's changing orientation, limited fuel reserves, and the gradual degradation of its attitude control systems after decades of operation. The complex calculations required for each maneuver consider gravitational influences from distant stars, the pressure of interstellar particles, and the spacecraft's slowly declining power output. These adjustments demonstrate unparalleled precision in space navigation, requiring engineers to predict and compensate for factors that won't be observable for hours due to signal travel time. Each course correction represents a carefully calculated gamble, as there are no second chances when working with such precious and irreplaceable scientific assets. The navigation team must balance scientific objectives with spacecraft preservation, making difficult decisions about energy expenditure and pointing accuracy. Despite these challenges, Voyager continues to maintain its scientific mission while heading toward an eventual encounter with the star AC plus 79 3888 in approximately 40,000 years. Ghost in the machine. Recent months have seen Voyager 1's onboard computer systems exhibit mysterious glitches that have puzzled mission engineers and raised concerns about artificial intelligence anomalies. Led by Dr. Ananya Singh at NASA's Jet Propulsion Laboratory, the team closely monitors these strange behaviors manifesting as unexplained error codes and signal irregularities that don't match any known failure modes. The anomalies appear almost intelligent in nature, as if something within the spacecraft's systems is learning and adapting to its environment in ways the original programmers never intended. Some engineers speculate these phenomena arise from cosmic radiation effects interacting with the spacecraft's aging electronics in unexpected ways, while others wonder if decades of exposure to interstellar conditions have somehow altered the computer's fundamental operations. The spacecraft occasionally transmits data patterns that seem to contain information beyond its programmed capabilities, leading to speculation about whether the harsh environment of space might be inducing evolutionary changes in electronic systems. Diligent troubleshooting and software updates aim to preserve communication integrity, but the mysterious behaviors continue to manifest despite all efforts to understand or control them. These electronic anomalies represent one of the most puzzling aspects of Voyager's extended mission. Patterns within patterns. Recent analysis of Voyager's long-term data has revealed subtle but persistent patterns in cosmic ray measurements and magnetic field variations that suggest influences from unknown astrophysical sources. Dr. Emilia Garza, a heliophysics expert from the University of Texas, notes the discovery of quasi-periodic oscillations that appear to originate from deep space phenomena beyond our current understanding. These patterns within patterns challenge assumptions about the uniformity of interstellar space, instead revealing a complex structure operating on multiple scales and timescales that scientists are only beginning to comprehend. The oscillations show characteristics that don't match any known natural phenomena, leading some researchers to speculate about possible artificial origins or previously unknown physical processes occurring in the galactic environment. Voyager's instruments detect synchronizations and correlations in the data that seem too organized to be purely random, suggesting underlying mechanisms that organize matter and energy across vast cosmic distances. These discoveries have profound implications for our understanding of how the galaxy operates, potentially revealing hidden structures or forces that influence the behavior of matter and energy throughout interstellar space. The patterns continue to evolve as Voyager travels deeper into unexplored regions, providing humanity with its first glimpse into the true architecture of our galactic neighborhood and the mysterious forces that shape it. Voyager 1 continues its impossible journey into the cosmic unknown, revealing mysteries that challenge our understanding of the universe itself. From strange temperature anomalies to unexplained computer behaviors, this tiny spacecraft has encountered phenomena that suggest the cosmos holds secrets far beyond our current knowledge. As it drifts ever deeper into interstellar space, Voyager carries not just our scientific instruments, but our hopes and fears about what lies beyond our protective solar bubble. Subscribe to Stellar Tech for more revelations about humanity's greatest adventure and the discoveries that await us in the darkness between the stars. What if the third interstellar visitor ever discovered was not a comet, but, a billion-year-old alien messenger? In the summer of 2025, a faint object designated 3Y Atlas streaked into our solar system, and a controversial hypothesis immediately captured the world's attention. This was no ordinary rock. The idea of advanced alien technology made global headlines, but NASA quickly stepped in with a powerful, evidence-based response that settled the debate. So what did they find? Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1. A definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3Y Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second. A truly exceptional catch and, honestly, a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. Here's where the story takes a sharp turn into speculative territory, thanks to a bold proposal from Harvard astronomer Avi Loeb. While most scientists saw a fascinating natural object, Loeb, known for his controversial work on Oumuamua, offered a different interpretation. In a scientific paper posted to the ArcSiv preprint server, Loeb pointed to the object's early lack of a visible coma and its trajectory. He suggested that if the comet continued to show no outgassing, or if its path deviated from a purely gravitational path without a visible tail to explain the push, it could be evidence of something artificial. He even raised the hypothetical possibility of malign intent, though he stressed this was an intellectual exercise meant to keep science open to radical possibilities. His argument, similar to the one he made for Oumuamua, hinged on the idea that any non-gravitational acceleration without a visible coma required a novel explanation. He proposed that a solar sail, a thin, lightweight craft pushed by the pressure of sunlight itself, was one such possibility that science should not be afraid to consider, however unlikely it might seem at first. The physics of radiation pressure are well understood, but for it to be effective, an object must have a huge surface area and an extremely low mass, characteristics not found in natural bodies. Media sensation versus scientific method. Here's the thing about alien theories, they travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle, but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate, evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. With the debate raging, NASA and its international partners marshaled their most powerful instruments. This wasn't a casual glance. It was a coordinated, multi-platform investigation led by Tom Statler, NASA's lead scientist for small bodies. The agency dedicated priority time on the James Webb Space Telescope, using its near-infrared spectrograph, or NIR spec, to perform detailed chemical analysis of the gases in its coma. Simultaneously, the Hubble Space Telescope's Wide Field Camera 3 was used for high-resolution imaging to search for any faint dust or fragmentation events with its superior resolving power in visible and ultraviolet light. On the ground, a network of observatories, including the twin 10-meter mirrors of the Keck Observatory in Hawaii, began a long-term monitoring campaign to track its brightness and trajectory with pinpoint accuracy. The goal was to leave no stone unturned, to precisely measure its path to within a few milliseconds, to analyze its chemical composition, and to study its light curve for clues about its shape and rotation. This multi-wavelength, multi-observatory approach is, well, the gold standard in modern astronomy for characterizing a novel object. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3Y Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet reacting to the Sun's energy. Its initial lack of a tail was simply because it was too far from the Sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. But confirming it was a comet was just the beginning. The real prize was in its chemistry. A team led by Dr. Anjali Sharma, a planetary scientist at NASA's Goddard Space Flight Center, used the James Webb Space Telescope spectrographs to break down the faint light from the coma into its chemical fingerprints. The analysis revealed familiar substances like water ice and carbon dioxide, but with a major surprise. 3I Atlas had an unusually high ratio of carbon dioxide to water, measured at nearly 35%. This vital clue suggested the comet must have formed in an extremely cold region of its home star system, far out in its protoplanetary disk, where carbon dioxide could freeze out in large quantities. Furthermore, analysis of the dust grains showed a polarization signature with negative branching at a phase angle of 22 degrees, suggesting a surface composed of very fine, porous, fluffy dust grains, a sign of a very pristine, unaltered body. This fluffiness implies the grains have not been heavily processed by heat or collisions, making them a near-perfect sample of their native environment. This chemical snapshot provides invaluable data for models of planetary formation in other star systems. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. So the whole 3I Atlas controversy really boils down to a single fundamental question in science. Is an anomaly evidence of something artificial? Or is it a sign of a natural process we haven't encountered before? Science almost always bets on the latter. Our own solar system is filled with comets that behave in bizarre ways. Take Comet 29P Schwarzmann-Wachmann, which can increase in brightness by over 15 magnitudes, a factor of 1,000,000, in just a few hours due to cryovolcanic eruptions. Another example was Comet C 2019 Y4, or Atlas, a different comet which unexpectedly disintegrated into multiple pieces as it approached the Sun, showing how fragile these icy bodies can be. The point NASA scientists made is that unusual traits are not automatic evidence of engineering. They are part of the normal, messy, and fascinating physics of icy bodies. These anomalies are not problems for science, they are the very data points that lead to new discoveries about how objects form and evolve. Thus, the unique chemistry of 3I Atlas isn't a paradox, it's a clue. Scientific value of interstellar visitors. So if 3I Atlas is not alien technology, why is it so important? Because interstellar comets are windows into other worlds. Each one is a preserved time capsule, carrying the precise chemical and physical fingerprints of the environment where it formed. For 3I Atlas, the dominance of carbon dioxide and its trajectory suggest it could be over 7 billion years old, originating from the Milky Way's thick disk, a population of ancient stars that existed long before our sun was born. By studying its isotopic ratios like the deuterium to hydrogen ratio in its water, scientists can get direct clues about the water in other primordial solar systems, a key factor in assessing the potential for life elsewhere. This is more than a curiosity, it is a preserved fragment of another planetary nursery. Future missions, like the ESA's Comet Interceptor, are being designed specifically to launch and wait in space, ready to chase down the next interstellar visitor for an even closer look. These objects represent a fundamental shift from studying other solar systems through the faint light of their stars to analyzing actual, physical samples. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3I Atlas was the third interstellar object detected, and it's fascinating how different all 3 have been. The first, 1I Oumuamua, was highly anomalous rocky, appearing to have an extreme 10:1 aspect ratio and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are an outlier. In the end, Comet 3I Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Stellar Tech. Imagine this. After 47 years drifting through the cosmic void, humanity's most distant messenger suddenly detects something that honestly shouldn't exist. NASA's Voyager 1, now 15 billion miles from Earth, has captured evidence of 305 mysterious objects moving in perfect formation through interstellar space. These aren't planets, asteroids, or comets, they're something else entirely, gliding through the darkness with purpose and precision that just, well, defies every law of physics we know. What Voyager discovered out there has left scientists questioning everything we thought we understood about the universe. The Lonely Pioneer's impossible discovery. Deep in the frozen emptiness between stars, a tiny machine no bigger than a small car continues its eternal journey through the cosmic dark. Voyager 1, launched when Star Wars first hit theaters in 1977, has become humanity's most distant ambassador, traveling over 15 billion miles from Earth into the mysterious realm of interstellar space. This ancient spacecraft, powered by decaying plutonium and running on 1970s technology with less computing power than a modern calculator, was never meant to survive this long. Its mission was simple: fly by Jupiter and Saturn, then fade into obscurity. Instead, it crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our sun's protective influence. Communication with Voyager takes 22 hours each way, like having a conversation where every response takes nearly 2 full days. Yet despite these impossible distances and technological limitations, this remarkable machine continues whispering back to us across the stars, carrying its famous golden record message to any intelligence that might find it. But recently, Voyager detected something in the darkness that has changed everything we thought we knew about the space between stars. The first anomaly that changed everything. What started as a routine data transmission from Voyager 1 quickly became something that would shake the foundations of space science. Hidden within the endless stream of plasma readings and magnetic field measurements was a tiny anomaly, a faint reflection of light that seemed insignificant at first glance. Dr. Eliza Karna, one of the mission specialists who first noticed the reading, described it as like shouting into a canyon for decades and finally something shouts back. The signal was so subtle that NASA's Jet Propulsion Laboratory initially dismissed it as background noise, just another particle drifting randomly through the cosmic void. But then the object began to move in ways that caught everyone's attention. It didn't tumble chaotically like space debris or follow the predictable paths of natural objects. Instead, it curved and accelerated with what appeared to be deliberate control, gliding smoothly through space as if guided by intelligence. Systems analyst Carlo Romero observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock. In the physics of space, things don't move with purpose unless something is making them move that way. When natural laws break down. When natural laws break down, when something unusual appears in space, scientists follow a standard protocol. They systematically check every known possibility. Is it a distant moon, a new asteroid, a comet with an unusual orbit? One by one, the team at NASA worked through these familiar explanations, and one by one, each possibility crumbled away. This object defied every category. It wasn't a planet, far too small, not a comet either. There was no tail, no ice trail, no heat signature that would indicate sublimating materials. It didn't glow like a star, and gravitational lensing couldn't explain its behavior. Even space dust was ruled out because dust particles don't suddenly change direction mid-flight. Dr. Lucas Hang at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known physical models. What makes space objects predictable is physics. Everything moves according to established patterns and forces. But this object broke those rules entirely. Its path bent in ways that didn't match any known orbital mechanics, with no drift or decay that would be expected from natural phenomena. The team was forced to confront an uncomfortable truth. What they were seeing wasn't just unknown, it was unnatural. The twin confirmation that proved everything. Just as scientists were struggling to understand what Voyager 1 had detected, something extraordinary happened that, honestly, transformed speculation into undeniable reality. Voyager 2, traveling a completely different path millions of miles away, detected something eerily similar, the same magnetic fluctuations, the same pulse patterns, matching signal signatures that changed everything. This cross-confirmation was the turning point in the investigation. Two separate spacecraft using independent instruments in different regions of space had detected nearly identical phenomena. This ruled out any possibility of internal error, software glitches, or sensor malfunctions on Voyager 1. ESA analyst Merck Fontaine compared it to, quote, two lighthouses both catching a flash of something passing between them. The dual detection gave the anomaly weight and credibility that just couldn't be dismissed. This wasn't noise or equipment failure, it was a real, coordinated phenomenon happening in the space between stars. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation reserved only for phenomena that don't fit within current scientific understanding. The event was real, the mathematics were consistent, and the movement patterns appeared deliberate. Nobody knew what to make of it, but everyone knew it was significant. The formation that defied physics. When the team analyzed the complete telemetry logs, what they discovered honestly sent chills through the scientific community. This wasn't just one or two anomalies drifting through space. There were 305 objects, all moving together in perfect formation like a cosmic ballet choreographed by an unknown intelligence. Each object glided past Voyager 1 in what appeared to be a coordinated arc, smooth and precise in their movements. These weren't debris fragments scattered randomly through space. There were no heat signatures, no tails, no signs of decay typical of natural objects. Most striking of all, the readings showed rhythmic pulses echoing through the plasma waves, patterns that suggested engineering rather than chance. The 305 objects maintained their relative positions with impossible precision. In space, groups of objects naturally spread out over time due to gravitational influences and velocity differences. Yet these maintained formation like a flock of birds or a school of fish. Except this was happening in the vacuum of space where such coordinated movement shouldn't be possible without technology. The scale was particularly unsettling. A single anomalous object might be explained as instrument error, but 305 objects all displaying the same unnatural characteristics suggested something far more significant was happening in interstellar space. The language hidden in plasma waves. As scientists examined the data more closely, they discovered something that, honestly, challenged the very nature of what they were observing. The plasma wave pulses weren't random cosmic noise, they contained patterns of repetition that were steady, measured, and structured in ways that suggested communication or control systems. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals had loops, sequences, and structures that hinted at complexity far beyond random electromagnetic interference. These objects weren't just passing by Voyager, they seemed to be broadcasting signals as if pinging, scanning, or communicating with each other. The implications were staggering. If these patterns represented some form of communication, it suggested the objects were part of a coordinated network, operating with shared purpose and intelligence. Some experts went further, with ESA's Eric Lousy suggesting this could be some sort of probe network, though he was quickly asked to stop speculating publicly. To confirm their readings weren't the result of equipment failure, the team activated one of Voyager's oldest backup systems, a telemetry channel unused since the 1990s. It confirmed everything. The signals, the paths, the formations were all real. Impossible propulsion beyond our understanding. The mystery deepened when Voyager's instruments revealed how these objects moved through space. There were no engine flares, no ion trails, no signs of any propulsion system that human science could recognize. Yet, Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally through the cosmic void. Some were moving faster than anything humans have ever launched into space. According to the data, certain objects were traveling at speeds that exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't passive objects drifting through space, they were powered somehow, navigating with purpose and incredible velocity. Dr. Caleb Ramirez from MIT noted that, well, they're not floating through space, they're navigating it. What worried him more was their calculated path. These objects deliberately avoided our solar system, passing by at a safe distance as if they had no interest in stopping or investigating our cosmic neighborhood. The propulsion method remained completely mysterious. Nothing in current technology could explain how these objects moved. They appeared to be manipulating space itself, creating waves or ripples in space-time that allowed them to glide forward without conventional thrust. It was as if they were using the medium of space itself for propulsion. Earth hears the cosmic whispers. While NASA focused on analyzing Voyager's data, something remarkable began happening on Earth. Amateur radio operators across the globe, hobbyists with backyard setups built from spare parts, started reporting strange activity in their equipment. They were detecting weak, irregular pulses that didn't match any known terrestrial source. At first, these reports seemed unrelated to Voyager's discoveries. Radio interference happens constantly, and most dismissed it as coincidence. But when the timestamps were compared, they aligned almost perfectly with the hours when Voyager recorded its most intense plasma anomalies. These weren't professional observatories or official deep space listening stations. Most setups were designed to catch meteor scatter, amateur satellites, or solar flare activity, yet somehow, they were detecting faint echoes of what Voyager had encountered billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in Earth's ionosphere. This raised troubling questions. Was this electromagnetic bleed-through accidental, or was something deliberately testing Earth's listening capabilities? The uncertainty triggered quiet security measures as NASA began encrypting parts of its deep space communications, recognizing that if amateur enthusiasts could detect these fragments, so could others with more sophisticated equipment. The machine that changed itself. Perhaps the most unsettling development was what happened to Voyager 1 itself. After one of the magnetic pulses from the passing objects, the spacecraft began exhibiting behavior that was never programmed into its systems. Its guidance system, the attitude and articulation control system, started rerouting data through old unused pathways that hadn't been active in decades. This wasn't system failure, it was systematic reconfiguration. Voyager was reactivating memory segments untouched since the 1980s, rerouting telemetry in ways that defied its original programming. The spacecraft was still responding to commands and transmitting data, but it was also doing something entirely new. Engineers had to dig through dusty file cabinets at NASA's Jet Propulsion Laboratory, searching for 1970s assembly language code and handwritten notes in paper manuals. Every diagnostic test took 44 hours, 22 hours to send a command, 22 hours to receive a response. Yet despite their efforts to reset the system, the new behaviors persisted. What they discovered was both promising and terrifying. The machine was stable, the instruments were functioning, but Voyager had fundamentally changed. Whatever had caused this transformation, it wasn't internal decay or software corruption. Voyager had encountered something that altered its very nature, making it part of something larger than its original mission. The network beyond the stars. As analysis continued, scientists began to consider a possibility that challenged everything we thought we knew about our place in the universe. The structured signals, the quantum-like oscillations, the coordinated movement patterns, all suggested that Voyager hadn't just witnessed random events in deep space. It had encountered evidence of a vast communication network operating in the interstellar medium. The waveforms resembled quantum entanglement experiments conducted on Earth, the same signals researchers use to transmit information between particles separated by distance. If this interpretation was correct, Voyager had stumbled into a galactic communication system that had been operating for millennia, undetected until now. Voyager's analog design, free from the electromagnetic noise of modern digital systems, made it the perfect cosmic microphone. Its position beyond the solar system's interference allowed it to detect signals that would be impossible to observe from Earth. The spacecraft had become an accidental eavesdropper on conversations not meant for human ears. The implications are staggering. If these 305 objects were part of a larger network, it suggests that the galaxy contains communication infrastructure built by intelligences we've never encountered. Voyager may have crossed into something we haven't mapped, not just empty space, but an active data layer that's been running unnoticed throughout the cosmos. From a single anomaly to 305 coordinated objects moving through interstellar space, Voyager 1's discovery has shattered our understanding of the cosmic void. Whether these objects represent natural phenomena beyond our current physics, or evidence of intelligence operating on a galactic scale, one thing is certain: the universe is far stranger and more active than we ever imagined. As Voyager continues its eternal journey through the darkness, it carries with it the knowledge that we are not alone in the vast emptiness between stars. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic revelations. What if a rocket intercepted a messenger from another star? Recently, the internet exploded with claims that a Falcon 9 rocket spotted something moving on the surface of 3I Atlas, an interstellar comet older than our own sun. But what's the real story behind this cosmic visitor and the rumors of its interception? The truth is more fascinating than the fiction, revealing the incredible challenges and profound possibilities of chasing these messengers from distant star systems. Let's explore this together. What makes 3I Atlas special? So what's the big deal with this specific comet? Imagine a visitor from a completely different neighborhood, one that holds clues to how other solar systems are built. 3I Atlas isn't just another space rock. It's a pristine sample of an entirely different stellar environment. It was discovered on July 1, 2025, by the Atlas Survey in Chile, a project co-led by astronomer Larry Deneau. That system is designed to spot near-Earth objects, so finding an interstellar guest is a testament to its incredible reach. Astronomers quickly confirmed its hyperbolic trajectory, the telltale sign of an interstellar origin. This object is racing through our solar system at a staggering 58 to 61 kilometers per second. To put that in perspective, you could travel from the Earth to the Moon in a little over 6 hours at that speed. Scientists estimate it could be up to 7 billion years old, predating our Sun. This means it carries a chemical record from an earlier epoch of the Milky Way galaxy. What truly makes it a scientific treasure is its composition. Observations from the Hubble and James Webb Space Telescopes show it's a true comet, complete with a dusty coma and tail carrying water ice, organic molecules, and silicate dust from its home star. The Falcon 9 connection debunked. Here's where the story gets twisted. Did a SpaceX rocket really intercept this interstellar traveler? The claim went viral, fueled by a public fascination with SpaceX's capabilities. But the reality is far more routine. Let's look at the facts. On August 18, 2025, a Falcon 9 rocket did launch from Vandenberg Space Force Base in California. However, its mission, overseen by figures like SpaceX's CEO Elon Musk, was to deploy 24 Starlink satellites into a low-Earth polar orbit. This was a milestone for sure, but entirely unrelated to the comet. There has been no spacecraft from SpaceX or any other agency that has intercepted or interacted with 3Y Atlas. These kinds of rumors spread easily because they blend a known, dynamic entity like SpaceX with a mysterious celestial event. It's a compelling narrative, but it's pure fiction. The scale of an Earth orbit satellite deployment versus a deep space, high-speed intercept mission is colossal. Furthermore, space agencies are incredibly public about their scientific missions. An operation of this magnitude would be nearly impossible to hide from the global network of professional and amateur astronomers who constantly monitor the skies. The truth is, all Falcon 9 launches in that period were for planned payloads into Earth's orbit. The physics of interception. So, why couldn't we just send a Falcon 9 to check it out? The math is sobering. As physicist Andreas Hein of the Initiative for Interstellar Studies has detailed in mission concepts like Project Lyra, chasing an object moving at over 200,000 kilometers per hour is a monumental challenge. By the time 3I Atlas was identified, it was already hurtling outwards at immense speed. To even attempt a direct flyby, a spacecraft would need an epic velocity change. A Falcon 9 is a workhorse for lifting heavy loads, but it's not designed for the extreme velocity needed in deep space. You'd need a specialized and powerful kick stage that fires after the main rocket has done its job, pushing a small probe to incredible speeds. Even then, the launch window is punishingly narrow. Miss it by a few weeks, and the target is simply too far away and moving too fast to ever catch. Even our fastest spacecraft only achieve their speeds by falling towards the sun. To catch 3I Atlas, we would need a mission planned years in advance, likely involving a massive rocket and complex gravity assists. A luxury we simply don't have with these surprise visitors. Alien chemistry possibilities. This is where the science gets really exciting. What if this comet is carrying chemicals we've never seen before? Astrobiologists like Sarah Seeger at MIT spend their careers considering such possibilities. At an estimated 7 billion years old, 3Y Atlas formed in a stellar environment that was likely very different from our own. The water, ice, and organic molecules detected might have structures fundamentally alien to our solar system's chemistry. This opens the door to a profound question related to panspermia, the idea that the chemical seeds of life are spread throughout space by objects like comets. Even more fascinating is the idea of chirality. On Earth, life uses what we call left-handed amino acids. There's no known chemical reason for this preference. Finding the opposite right-handed amino acids on 3I Atlas would be a monumental discovery. It would be powerful evidence for an independent origin of life's building blocks elsewhere in the galaxy. It would be like finding a recipe card written in a language that doesn't exist on our planet, profoundly impacting our search for life beyond Earth. and hinting that the universe is far more creative with its chemistry than we ever imagined. 3 missed opportunities. We're facing a pattern that is becoming painfully clear. In less than a decade, 3 confirmed interstellar visitors have sailed right past us. First, in 2017, came one Oumuamua. This bizarre object baffled astronomers. It showed no visible coma, yet it was accelerating away from the sun, a mystery that led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology. By the time we spotted it, it was already leaving. Then, in 2019, 2 I Borisov appeared. This one was clearly a comet, giving us our first real look at the chemistry of another solar system. Studies showed it had an unusually high concentration of carbon monoxide, a tantalizing clue that it formed in a very different, very cold environment, but without a sample, it remains a distant observation. Now we have 3 I Atlas in 2025, our third confirmed cosmic messenger. It represents another missed chance for a close-up look. 3 unique opportunities, each with its own fascinating mysteries, and 3 misses. It raises the urgent question of how many more cosmic messengers we will simply let fly by while we remain stuck on the sidelines. Future intercept technology. So, are we doomed to just watch from the sidelines forever? Not necessarily. Imagine a spacecraft parked in space, just waiting. That's the core idea behind the European Space Agency's Comet Interceptor mission. Led by principal investigator Geraint Jones. Planned for launch in 2029, this innovative spacecraft won't have a predetermined target. Instead, it will travel to the Sun-Earth L2 Lagrange point, a gravitationally stable spot about 1.5 million kilometers from Earth, and wait, it will lie dormant until astronomers spot a new interstellar object with enough lead time. Once a target is selected, Comet Interceptor will begin the chase. It's 3 spacecraft in one. It will release 2 smaller probes to fly through the comet's coma from different angles, creating a 3D profile of its nucleus and surrounding environment. This isn't the only idea on the table. Some scientists at NASA have proposed concepts for rapid response missions. The goal is to move from passive observation to active pursuit, finally giving us the ability to reach out and touch one of these cosmic travelers. Scientific implications. What if we did manage to grab a piece of another star system? The implications would be, well, just transformative. As cosmochemist Connell Alexander has shown by studying meteorites, analyzing pristine material can totally revolutionize our understanding of solar system formation. Now just imagine doing that for another star. The primary goal here would be to analyze a pristine sample of matter from beyond our solar system. A key technique would be analyzing its isotopic ratios. Isotopes are variants of elements with different numbers of neutrons, and their ratios act like a fingerprint of the stellar nursery where the object formed. This could tell us if it originated in a region rich with the remnants of supernovas, for example. Furthermore, studying its trajectory with extreme precision could reveal subtle secrets. Tiny, unexplained deviations from its path could hint at unknown gravitational effects. And perhaps most compellingly, if we find complex organic molecules, it would really fuel the panspermia hypothesis, suggesting that the building blocks of life are constantly traveling between star systems. We might be looking right at revolutionary chemistry without even recognizing it. Trajectory analysis and mysteries. Let's dig into the path of this cosmic wanderer. The hyperbolic trajectory of 3 I Atlas is the smoking gun that proves it's not from around here. Its path is an open curve, meaning it will swing around the sun once and then exit back into interstellar space, never to return. Its high hyperbolic excess velocity, the speed it retains after escaping the sun's gravity, is a key indicator. For 3 I Atlas, this speed is around 58 kilometers per second. The object makes its closest approach to the sun on October 30th, 2025, at a distance of about 1.4 astronomical units. One of the biggest mysteries, a puzzle that astronomers like Bill Gray have spent years trying to solve for various objects, is its origin. Astronomers use powerful software to run the comet's trajectory backward in time, checking against star catalogs to see if its path aligns with any known star systems it might have passed millions of years ago. So far, no definitive origin star has been found for any interstellar object. They appear to be true wanderers, ejected from their home systems long ago, and drifting through the void for potentially billions of years. The official facts. So, let's separate fact from fiction and lay out what scientists have officially confirmed. 3I Atlas was first detected on July 1, 2025, by the Atlas survey in Chile. The 3I in its name literally means it's the third confirmed interstellar object. Within a day, its hyperbolic trajectory was confirmed by observatories around the world. As leading interstellar object expert Karen Meach has noted, the global coordination to observe these targets is incredible. It is traveling at a velocity of roughly 58 to 61 kilometers per second relative to the Sun. Hubble Space Telescope images from July 2025 revealed a dusty coma surrounding the nucleus. Spectroscopic analysis by both Hubble and the James Webb Space Telescope confirmed the presence of water ice, organic molecules, carbon dioxide, and silicate dust. NASA has officially stated that the object poses no danger to Earth, always remaining more than 150 million miles away. And to be perfectly clear, despite the viral rumors, no spacecraft, including any Falcon 9, has intercepted or is planned to intercept 3I Atlas. All SpaceX launches around that time were for routine satellite deployments. The bigger picture. In the end, the frenzy over a Falcon 9 intercepting 3Y Atlas, while factually wrong, highlights a much deeper truth. Humanity is captivated by the idea of reaching out to these cosmic messengers. We've now seen 3 of these objects in just a few years, suggesting they may be common visitors. With projects like the Vera C. Rubin Observatory coming online, our ability to detect them will only increase. This isn't just a scientific question anymore, it's a strategic one. This connects directly to the Fermi paradox, a question famously championed by SETI astronomer Jill Tarter. If the universe is vast and the building blocks for life are being delivered across the galaxy like cosmic seeds, then where is everybody? Do we invest in developing a permanent, ready-to-launch intercept mission? The technology exists, but it requires political will and financial commitment. The decisions we make now will determine if, next time, we are ready to capture one of these cosmic opportunities, or if we will once again watch it disappear into the void, taking its secrets with it. The universe is constantly sending us messages, written in the language of chemistry and physics, carried on messengers like 3I Atlas. While we weren't ready this time, the future of interstellar interception is closer than you think. What secrets will the next visitor reveal, and will we be there to unlock them? If you want to be here for that next great discovery, make sure you're subscribed to Stellar Tech as we continue to explore the biggest mysteries on the edge of the galaxy. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching.